All right, today's lecture we're looking at operations with radicals, but specifically we're looking at how you multiply radicals. So my instructions here are perform the operation and then simplify. So here a good rule of thumb is when you are multiplying radicals, you want to make sure that you combine the radicands underneath the same radical. So all of the ones I'm doing with you are square roots. So I'm going to take the two numbers that are underneath the square roots and combine them underneath the same radical. So let me write that in words at the top. So we're going to combine the radicands, so fancy way of phrasing it, but your radicand is just the number that's underneath the radical. So it would be like the 7 right here is your radicand. So combine the radicands together under the same radical or the same square root, which will be all of our examples today. So combine the radicands together underneath the same radical. And again, to be more specific, we are looking at square roots today. Okay, so in problem 1, I have the square root of 7 times the square root of 7. So I'm going to draw a big square root and put the two 7s underneath. So now I can see, oh, I really have a pair of 7s underneath the same radical. For every pair that I have underneath the same radical, I pull them both outside and I write 1 on the outside to represent the pair that was underneath. So this ends up being just 7. So that's a nice thing to remember. If I multiply a square root by itself, so if I multiply square root of 10 times the square root of 10, for example, it's going to give me a pair of 10s underneath the same square root. So it's going to become just 10 overall. So whenever I multiply a square root by itself, again, I get the pair underneath, so it ends up becoming just the number that was in the radicand initially. So square root of 3 times square root of 3 would be just 3, for example. Okay, problem 3. I have the square root of 6 times the square root of 12. So sometimes we write it just right next to each other like that. We don't put the times sign in between, but it's implied that it's there. So this reads as the square root of 6 times the square root of 12. So I can do the same thing. I can draw a big radical, my square root, and I can put a 6 times 12 underneath. So again, I'm looking for pairs, and when I look at that 12, I know that that's 6 times 2, which will then give me a pair of 6s with that 2 that stays behind. So on the outside, I would have a 6. Underneath, I would have a 2. So my answer here would be 6 times the square root of 2. Okay, let me slide up to 5. So again, I'm going to do the left-hand side, and I'm going to have you guys do the right-hand side in just a moment. All right, so problem 5. So I have 3 times the square root of 5 times 2 times the square root of 15. So this really reads as 3 times the square root of 5 times 2 times the square root of 15. Okay, so even if we don't write the multiplication sign in between the 3 and that square root of 5, it's still there. So I'm just making sure that you see it that way too. So now I'm just going to reshuffle because the order that I multiply these 4 components, it doesn't actually matter. So I'm going to reorganize it with the 3 and 2 next to each other. And then I'm going to put the 5 and the 15 underneath the same radical. So underneath the same square root. And then I'm looking for pairs. So in 15, I can see that that's going to be a 5 times 3. Here's a pair of 5s. Here's that 3 that's going to stay behind. So on the outside, I have the 3 and the 2 that were already there, joined now with a 5, right? Because I have a pair of 5s right here. And then that little lone 3 stays behind just like that. And when I multiply the 3 times 2, that's 6 times 5. I get 30 times the square root of 3. 30 root 3, just like that. All right, for 7, I have 4 square root 6 squared. So that really tells me that it's 4 root 6 times 4 root 6. Which again, just to be super clear, that's like saying 4 times the square root of 6 times 4 times the square root of 6. So I have these 4 components. It doesn't matter how I multiply them. So I'm going to reorganize them. I'm going to put the 4 next to the 4, and I'm going to put those root 6s together, right, underneath the same radical. So I have a pair of 6s underneath the same radical. So this becomes 4 times 4 times 6, so 96 overall. Okay, and then the last one, and then I'm going to have you guys pause, and I want you to work through the right-hand side. So last one before we hit pause. So here I have the square root of 2 multiplied over these 3 terms. I have a 5 plus square root of 2 minus 4 times the square root of 6. So I really, since I just have a single term on the outside, I have to distribute that square root of 2 over these 3 items just like so. So I'm just going to distribute. I have the square root of 2 times 5, so that makes 5 root 2. Next, I have the square root of 2 times the square root of 2. So those combine underneath the same radical, which is going to leave me with a 2 overall. So right now I have 5 square root 2 plus 2. And then minus, I have the square root of 2 times a negative 4 square root 6. So here minus 4 will go first. And then underneath the radical, I have the 2 times the 6. So if I'm looking to simplify that, that 6 is 2 times 3. Here's a pair of 2's, that 3 staying behind. So this will end up being 4 times 2 root 3, which is 8 root 3. So if I clean this up, I have 5 root 2 plus 2 minus 8 root 3. I don't want you to worry about the order of writing these 3 terms. The order that you write it in does not actually matter. So leaving it like this would be fine. If you put the 2 first, that would be fine too. All right, please hit pause. I want you to work through the right-hand side, and then when you're ready, you can check it against my answer key, or you can watch me go through this next batch of 5. So when you're ready, unpause, and here we go. So again, just to remind you, when we are multiplying, we can combine the radicands together underneath the same radical, so underneath the same square root. All right, so first up, I have the square root of 5 times the square root of 5. So if I put them underneath the same radical, just like so, here is a pair of 5s. So when I multiply the square root of 5 by itself, right, I get that pair underneath, and it becomes just 5 overall. All right, next one in problem 4, I have the square root of 10 times the square root of 20. So again, I can draw a big radical, put the 10 and the 20 both underneath, just like so. So what I can see is that that 20 will give me another 10, because 20 is 10 times 2. So I have a pair of 10s, and I have that 2 that's going to stay behind. So on the outside, I have a 10. Underneath, I have a 2. So 10 square root 2, 10 times the square root of 2. All right, next up. So in 6 here, I have negative 5 times the square root of 8 times 4 times the square root of 6. So again, just to see things clearly, right, everything is being multiplied. I'm just going to add clarity to that, right? Everything is being multiplied. That's what it looks like. So now I can reshuffle it. I'll put the negative 4 and the negative 5 next to the 4. So I'll put those 2 together. And then underneath the radical, I have the 8 times the 6. So now I'm looking for pairs underneath the radical. So for 8, I can see, well, that's 4 times 2. That 4 is going to give me a pair of 2's. That 6 is 2 times 3, so I have another pair of 2's, and then a 3 that's going to stay behind. So on the outside, I have negative 5 times 4 times 2 times 2, and then underneath, I have the 3. So the 3 stays underneath the radical. So if I multiply this back, I have negative 5 times 4, so I have negative 20 times 2, negative 40 times 2, negative 80. So negative 80 times the square root of 3. All right, 2 more. So in problem 8, I have 2 root 5 squared. So this reads as 2 root 5 times 2 root 5. And then again, of course, just to make sure that's clear, 2 times the square root of 5 times 2 times the square root of 5. So now again, I'm just going to reshuffle it, put the 2's next to each other, and put the 5's together underneath the radical. All right, so now I'm looking for any pairs. I have a pair of 5's. So this reads as 2 times 2 times 5, which gets me to 20 overall. Okay, last one. Here I have 1 term on the outside, 3 terms inside of my parentheses. So I'm going to have to distribute that square root of 3 over those 3 items, just like so. So if I have the square root of 3 times 9, that's 9 root 3. Okay, minus, I have a square root of 3 times the square root of 3. So I'm going to write those 2 3's together under the same radical, which I know gives me a pair of 3's and becomes just 3. So right now I have 9 root 3 minus 3. And then last part to multiply, I have the square root of 3 times 5 square root 12. So I have a 5 on the outside. Underneath I have a 3 times 12. So when I look at that 12, I can see, well, that's 3 times 4. Now I have a pair of 3's. And then 2 times 2. Now I have a pair of 2's. So I really have 5 times 3 times 2. 5 times 3 is 15, times 2 is 30. So plus 30. And then I can combine like terms when I'm adding or subtracting. And in this case, I do see like terms. I have these integers right here. They can combine. So here, if I have a negative 3 plus 30, that's 27. So I have 9 root 3 plus 27. And that's my final answer. And again, if you switch the order, that would be fine. It really does not matter here which one you put first. All right, that's all I have for today. Have a good rest of your day.